All right, so we're ready to go. It is 6 o'clock. First off, I want to thank everyone for coming out so late. For coming for my talk, I guess there's a lot of competition here. I unfortunately am not as funny as some of the other talks right now. So, all right. So this is staying persistent in software-defined networks. My name is Gregory Picket with Hellfire Security. I am part of our cybersecurity operations group. An overview of today's talk. White box Ethernet. What is it? It's not common knowledge right now. It's started emerging, really. After that is stupid is as stupid does. Next is exploiting it. I'll point out a number of weaknesses and what we can do to take advantage of them. Next is moving forward. All right, how do we remediate, ultimately mitigate those weaknesses and the vulnerabilities that they involve? And then finally wrapping up. All right, where is all of this taking us and what we're trying to accomplish, what I'm trying to accomplish with talks like this. Okay. All right, let's start out with white box Ethernet. Okay. Well, it's standard hardware. Right? It's a blank slate running merchant silicon, Trident and Broadcom chipsets, right? Intel, AMD PowerPC processors, using an open operating system that is often Linux. But I don't think I've seen anything that wasn't Linux. Right? The idea is to remove the hardware from the equation, to make it a commodity by using off-the-shelf components. So from that point forward, it would be the software that made the difference. Right? It's critical for software-defined networking, right? But it can be used without it. Of course, the question is, why do it? Why are we moving in this direction? Well, it's the same reason why they're implementing software-defined networking. Reducing the cost, increasing the flexibility, looking, of course, to gain more control. You can gain the control through traditional means. You can actually remote to white box Ethernet switch, right, SSH. You can issue commands to define the switch, to configure the network, just like you would, right, a regular switch, traditional switch. You can also script for management purposes, or you can load an agent on it, like Puppet or Chef, to make it part, DevOps, right? Just network automation, orchestration. Yeah. Or you can gain that control with software-defined networking. All right, with software-defined networking, the control plane is centralized in controller. This makes the network flexible and, of course, responsive, right? Everything's in software. With white box Ethernet, your hardware data plane, no problem, right out of the camera shot there. All right, with white box Ethernet then, right, the data plane becomes just as flexible. Right? You can just use whatever hardware you want. You're not tied to vendors, proprietary hardware, your technology, any sort of commands. You learn, the Cisco certifications that are required, those sorts of things to point out one particular vendor, right, that you get hooked up with and then you're kind of stuck with for life. All right. Now, to make all of this possible, right, to make white box truly plug and play, they adapted ONI. It's firmware for bare metal network switches. There's a bootloader underneath, right, which grub or U-boot to boot the system, and then ONI is there to boot the network, right, to grab or install the network operating system, and in the event you'd like a new one, like you have to change the software, it will then go out and grab another network operating system and install a different one. Right? You can change whenever you like. ONI comes pre-installed on the network switch. It's part of the firmware, and it automates that switch deployment. Okay. So white box Ethernet, the blank slate, and ONI the network bootloader. What could go wrong? There are a number of weaknesses in the operating system. ONI itself actually is Linux-based, right? The privileged account, the root has no password, and ONI does not force you to change the password, so it's likely to remain stale. Management services, well, it uses Telnet, right? Insecure by design, ultimately weak. SSH is weak too. Installation mode, the key is only 18 bits of entropy there. Recovery mode, 26 bits of entropy. Not looking good so far. The installer has weaknesses as well. It uses a predictable set of URLs, right? It's defined in the standard. goes to basically one URL first, and another URL after that. Basically goes through a series of URLs that are defined by the standard, right? The process it does or carries out to install, and where it goes is very defined in the standard. First off, you get or gets an exact URL from DHCP from an assignment. After that, it'll build a URL from the DHCP response. After that, it'll look to its IPv6 neighbors for an installation, and then following that, all that failed, it'll go ahead and go through a TFTP waterfall. And so it's very predictable where ONI is going to be looking. And when it arrives at a particular location, it goes ahead and looks for particular files, right? It goes through a series of file names that are defined, again, by the standard. So, as an attacker, you can pretty much know ahead of time where ONI is going to be looking, and you know ahead of time what ONI is asking for, so you can actually hand ONI a compromised installation, and ONI will install it. Right? And that's possible because there's no encryption nor authentication. Now, should you hand ONI a compromised installation, or any sort of installation, once that network operating system is running, ONI's partition is exposed. Right? It's exposed, it can be modified. It can itself be compromised. And with no secure boot, there's really nothing to stop that compromised installation, that compromised ONI from continuing to operate over and over again and doing whatever an intruder is told to do. Right? What does this mean, of course, with all these weaknesses? There's lots of opportunities to blow ONI up. It is not very well protected. So you can blow it up. And the first thought, of course, is compromise it directly. With a root password that starts out blank and it's likely to remain stale, you could, of course, log in, right? We could sniff the traffic or perform man-in-the-middle, modify traffic flows through Telnet, or by easily cracking SSH, but that's not likely. ONI is up, I'm just throwing a number out, 0.00001% of the time. Its job is to install the network operating system all 45 seconds. Once it's done with that, it sets a boot variable, which basically says from that point forward, boot to the network operating system, reboots the switch, and then the network operating system runs for the rest of that time, right, the 99.99% of the time. Next thought is then can we compromise installation, right, be a rogue DHCP server, a friendly IPv6 neighbor, or maybe spoof a TFTP server. It's also very difficult, right? It's like right place, right time. If you happen to be there at the right time, you get it, you get a compromised installation to it, so you're there for a while, right? You're there for however long the operating system lasts, but you don't gain that nirvana of hackerdom, right, which is persistence. Right? It's not likely you're going to be in the right place at the right time again. So is there a better way? All right. Compromise it indirectly. The network operating system is going to be up for 99% of the time. See what you have to work with. Get past the network operating system, modify ONI. Right, it's an exposed partition, right? Sitting there. Take advantage of that. Compromise ONI. No secure boot to stop you from doing this and take advantage of ONI there. So over and over again, this will regain your persistence, right? ONI will keep doing whatever you tell it to do. So if you compromise the network operating system, you're able to compromise ONI, then anytime a new network operating system is installed, you're basically back again. Right? Because now you're in the firmware, you're essentially there forever. And that's what we're looking for, right, as attackers. Or as, of course, white hat penetration testers, we're looking for that persistence. Okay. So, network operating systems. Installed by ONI, operate the switch to actually do all the packet forwarding and provide all the different features that you like to see in a switch. ONI compatible distributions, right? There are a lot, actually, of network operating systems, but only a handful right now that have ONI compatible distributions. The number's growing, and they just added Picket 8, I think, a couple months ago. But when I started this, there's only about 4 that were really prevalent. First is Open Network Linux. After that is Switch Lite, Cumulus Linux, and Mellanox OS. Open Network Linux, Linux distribution for bare metal switches, as they all are, of course. Based on Debian Linux, this is very popular. It's bare bones with no features. It will run the switch, but you're going to have a real hard time defining the switch, configuring the network, because really it's just a reference. It's a starter that the Open Compute project came up with. They want you to use this to develop your own network operating system. They're obviously there to promote ONE. So they're giving you the starter so you have something to work with and you can actually make something that will run with ONE. Right? And that's what Switch Lite did. I looked at version 2.6. It's a packaged Open Network Linux. They took that starter. They added SL REST, which operates a lot like OVSDB to define the switch. Added Indigo OpenFlow agent for loading of the flow tables, or to configure the network. This is not a standalone though. It really is part of a total solution called Big Cloud Fabric. All right. The idea is to plug the switches into the network, and then Big Cloud Fabric just takes over. And you're actually discouraged from managing the switches. You are, for all intents and purposes, at least the way I look at it, to abandon that switch to Big Cloud Fabric. We will see how well that turns out. Okay? And of course, the total solution is maintained by Big Switch Networks. Cumulus Linux looked at 2.5.3. It's important to know that I'm looking at the latest versions, right? So I want you to know what those versions were. It is based on Debian Linux as well. You would install Puppet, Chef, Ansible. It's because it's meant for a DevOps environment, right? Managed with the rest of your infrastructure. And it's maintained by Cumulus Networks. And finally, we have Mellanox OS. This is version 3.3.4. It's based on Enterprise Linux 5. There's actually a newer version 3.4. But it turns out all the problems that 3.3 has, they're still there in 3.4. So, just how you should know that. You would install Puppet, Chef, Ansible to make it part of a DevOps environment, or eSwitch to make it part of an SDN environment. So it's very flexible. Okay. Maintained by Mellanox Technologies. All right, so of course, this is what I do here. I'll introduce you to these and then talk about really the weaknesses. No encryption nor authentication on Switch Lite's Indigo, nor Mellanox OS eSwitch. With Indigo, it's just a matter of spoofing the controller. eSwitch, you just talk to it. It'll listen to whatever you tell it and just do whatever you tell it to do. Okay. Well, outdated OpenSSL. This was done because, honestly, I needed to fill out the fly a little bit. So, yes, I didn't want a lot of blank spaces. So, Switch Lite, they are running a bit behind OpenSSL. And when I saw it, of course, I'm thinking Heartbleed, and I did check that, and Heartbleed is not a problem. So that's good. But still, as someone who looks at these things, who looks at how hardened these environments are, I don't like to see old software. I don't think any of us do. Okay. So, with no encryption or authentication, then these, of course, are vulnerable to topology flow and message modification through unauthorized access. Add access, remove access, hide traffic, change traffic. It's been mentioned, I think, in the press a bit about eavesdropping. And that's, of course, something that is likely to happen on a Switch Lite network or Mellanox OS, right? Mellanox running eSwitch. Okay. But there are bigger problems, and this is what's going to end up leading to the persistence. All right. We start off with something rather simple. Default and fixed accounts. Switch Lite has admin. Cumulus Linux has Cumulus, and Mellanox OS has admin, which are their low privileged or safe accounts. This is a big deal for two reasons. The first is that you have a limited ability to add other users, so you are kind of stuck with these guys. You're stuck using these. All right, the exception is Cumulus Linux, but I'm going to show you some command injection to get around any sort of limitations that they might try to put on you. All right, so I'll show that in a bit here. And then the second reason this is a big deal is because these accounts are the only obstacle to getting root on the switches, right? Which doesn't sound good, right? Just a little targeted keylogging and the switch is yours. And then the network. All right, and this is where all that begins, right? Easy escape to shell. Switch Lite uses a wrapper. Type enable, debug bash, you are at the shell. Right? Cumulus Linux, you actually connect directly to the operating system, so you don't need to do any escape. You are already at the shell. Mellanox OS, well, it has a very well done shell. However, Puppet's there, and Puppet can do dirty work for you. So Puppet will actually open up a back door, which of course is not in the documentation, but you will find it if you unpack the firmware. Okay? Always helpful. And once you have that shell, you get instant elevation. You immediately become root. On switch light, turns out admin is UID 0. So when you have that shell, you immediately are root. So Cumulus, you basically have unrestricted sudo access. So you are a root equivalent. Also not good. And Mellanox OS, you start the back door with admin. So it's running under admin's privileges, and when you X the back door and you take a look at your UID, it turns out you are also UID 0. So that's also root privileges. All right, that one password, get that out of the way. And we know that compromising a workstation is trivial, keylogging is trivial, right? Leads to full control of your network. First the switch, and then the network through unauthorized access, add access, remove access, hide traffic, change traffic, all three operating systems. And then of course, compromise of the firmware through unauthorized access, because root gets you access to the flash. Get you access to ONI, you can do whatever you want with it. You modify it, and you have your firmware compromised. Okay. So this means your network is one keylogger away. All right. I'm going to show you this here. Last year, I did open source, right? Easy to get access to. And people would always ask about vendor products, because, you pay money, good money for the vendor products, and you wanted to see if the money that you paid, was worth it. So this year I decided to make a point of using vendor products and to actually run tests on vendor products, things that you paid for and expect to be better secured, right? That's what they claim, and in a lot of cases they are, but we always want to make sure that they are what they say they are. So I started looking at these vendor products, and these are all vendor products running on equipment, right? Network equipment. I started with Big Cloud Fabric Controller, and I logged in as admin, a low privilege user, looked through the commands, and I found debug bash, and I liked the word bash, that sounded good to me. And I went ahead and got the shell there. And if you're paying attention on the account slide, right, you saw root that was hidden and disabled. Said they wanted you to stay away. They just actively discourage you. Switch light actively discourage you from, touching the switch. Right? They want Big Cloud Fabric to really take care of everything. So with that in mind, we have that hidden and disabled account. Right? They don't want you to touch the switch. They don't want you to touch that. Well, there's no password on that. So how likely are you to change the password? Right? All that hidden and disabled does is keep you from logging in. Once you have shell, you can go ahead and switch over with no password. Then you are, of course, immediately root there. So I'm thinking to myself, I wonder if I can do that on switch light. Okay? So I log in as admin. I had to do a little extra work there. I typed in enable first, debug bash, and then I came up as root, and I was a bit surprised. So I checked out my UID, and it turns out that I'm UID 0. So I like that. Then we have, yes, switch, so we have our access, right? So we have our access there as root. So we can start looking around for flash, right? For flash devices. And we can look for one that's nicely named, of course, right? ONI. And we see that with the privilege we need to write to it, right? With the root. So that's good. We got that. Cumulus, all right? I want to show you can basically, I call it sudo it up, right? You can go ahead and cat shadow, you can change the password to root, you can switch it, you can do whatever you want, right? Sudo, everything. And then Mellanox. Right? I open the back door. I will tell you what that is soon. At the end there, save it for last. Netcat, very useful. And I want to connect it to the back door. Admin, obviously. And then I cat etc password, and there I am again, admin at UID 0. And then an extra account, maybe for always good to know other ways to get in. Extra account there, UID 0, excellent admin. All right. And I mentioned that with Cumulus Linux, there were ways to restrict your permissions. And since you are dealing directly with Linux, you can add new users. Right? There are some command injection problems, though, in the tools that Cumulus Linux gives you for low privilege or less privileged users. They let escape any sort of salute limitations. And so sorry, Cumulus Linux, they do know about this. Okay? Now, I don't come out with a lot of 0 days or any sort of, brand new, vulnerabilities in products. So I like to celebrate this a little bit. I like to show off up there. So, yes, big across the top there. All right, Cumulus Linux has several command line tools, right, that they have set aside for less privileged users. I won't name them because they're tongue ties. They're meant to be used by low privilege admin accounts. People said that's just taking care of the switch. You go ahead and you enter your arguments, which end up being subcommands and parameters. Those subcommands and parameters get passed to CL CMD server. I can say that pretty well. And that goes ahead and compares it against a Rosetta. Rosetta is basically, this is what's acceptable. And if it's acceptable, it lets it through. The problem is there's command injection. And so that's filtering basically. And there's command injection that allows you to bypass the filtering. So you basically get to have CL CMD server do whatever you want, whether it's in the Rosetta or not. And it runs as root. So any sort of pseudo limitation they put on you, you can go ahead and sidestep those. Okay. I'm running on a switch again, right? So here we go. That is a switch with a license, and hopefully I'm not violating any licensing agreements that I might have signed. EULAs. So there it is running on a switch there. CL CMD server. Okay. I'm going to go and demonstrate this. I did bring VMs, right? I'm not as resourceful as the guys that apparently brought a whole safe out here. Yeah, I didn't want to try to ship or carry a top-of-rack switch onto a plane. So we're going to go ahead and make sure I get my address for this. I think I already have it. I'm a low privilege user. I got lots of VMs running here. It'll take just a second here. Okay. Is it clipped again? Oh, it's off the screen again. All right. There you go. I have a touchpad up here. Never good at it. All right, so I'm going to go ahead. I'm greedy. And of course, I have my salute limitations. I'm that low privilege user. And let's say I figure out the command injection. They have a patch for this already. So I don't feel so bad about revealing this in complete detail. So I have that one tool that I have pseudo privileges for. All right, and there is my arguments. What I've done is I've injected so that my second command, right, my injected command looks like it's part of the label. And you have to do that. And you have to, otherwise it looks at that label, that first piece as a command and tries to process it. And of course it's not in the Rosetta and it fails. So I need to shove it all together so it sees it all as a label and it ignores it. Yeah. It is a VM, there's no guts back there. So it does say unknown command, but it injects nonetheless. Now, you'll notice there's no spaces there, and to get around that, you go ahead and just make a script. Right? You put a script in your very own low-privileged home directory, and you put out any kind of command you want in there, and what this one did, someone asked that before, it just adds another user with no pseudo limitations. You can sudo anything. So we can go ahead and, yes, it's a little bit of a cliche. And so, there you go. Then I have everything there. No collapse? Thank you. Thank you. We work all year for claps. Come on. All right. Thank you. Now I feel satisfied. I feel fulfilled. All right. So you can bypass any sort of pseudo limitation with that and get your root change or password change, and then use a root account. But obviously you don't want to do that. You don't want anyone to know that, you're around. All right. I'm going to go ahead, exit, and then pause my VM so I can release resources. All right. Am I back on the screen all the way? Okay, good. All right. So once you, of course, have the root privileges, this is, once again, a live switch. You can go ahead and you can look at the MTD devices and find ONI and then dump from the block device. And you have your privileges you need right there to modify it and put it back. Okay. Now, a big part of this is implications, right? There's been talk about this, of course, especially on the vendor side, that this is a common problem, right? We have grub and other issues with different types of devices. It's important to know that, first of all, implications are greater, right? If you have a firmware compromise on a single server, yeah, there's important data, but it's a single server. If you have a firmware compromise, firmware compromise is now possible on your switch, then you have your network, right? You have the network gone. One server, whole network. One server, whole network. There's bigger implications. And it's important to talk about how this is done, because they assume, first off, that it's behind a firewall, it's safe. So we want to talk about scenarios that really are very possible, that make it not as safe as they think it is. So I'm going to play the GoTeed, your network administrator. And this can happen a number of different ways, right? You can browse the internet, you can get a drive-by download, you can open a bad attachment. In fact, that's what I'm going to go ahead and do. And I'm going to be infected by a piece of malware, a POC I put together called Big Brother. Now, what Big Brother is going to do, it's a Windows binary, it's going to infect the Windows system. All right. It's going to go ahead and it's going to keylog off those fixed accounts, the ones that you're stuck with, right? For simplicity's sake, very easily could have keylogged off connections to the switch. Okay. Once Big Brother sees one of these accounts in use, keylogs the password. As a network administrator, you're going to touch a switch at some point in time. You're going to log in, and it just waits around for that. As soon as it sees you do this, and as soon as you're done, well, he logs in. Okay. He logs in, and he writes a Linux-compatible binary to the switch's file system. Nothing's downloaded from the internet, carrying the secondary payload himself, right? He's carrying Little Brother, writes it out, starts Little Brother as a backdoor. He unpacks the firmware, shoves Little Brother in there. I mean, what are Big Brothers for, right? Reps ONI back up, puts ONI back. Now, before he does this, he modifies ONI so that anytime ONI installs an network operating system, ONI also puts Little Brother back. And that's a persistence over and over again. No matter how many times you install a network operating system, Little Brother keeps coming back. Okay? But it doesn't stop there. He is a Big Brother. He helps out. He pivots. He connects Little Brother as a backdoor, and then he also connects out to a C2 server. And the C2 server can be anywhere. Okay? This helps get past things like VLANs, ACLs, firewalls. What he does is actually he browses. It's a reverse HTTP shell. Uses headers, and he's capable of using a proxy. So it likes to blend in. And he's going to relay commands between Little Brother and the C2 out in the great wide world. Okay. All right, so we're going to go ahead and demonstrate this. A bad attachment here. I'm not a malware writer, so it's not completely, it's a little bit stealthy, but not really. He does hide a little bit, but it's still not hard to find. All right. So make sure he's running there. Then, as a network administrator, I've got a jacked up attachment, and I move on with the rest of my day. At some point in time, I'm going to go ahead and touch that switch. It just the way it works. Okay. This has a wrapper just like Switch Lite. All the same commands to get to the shell. Right? This is actually what Big Brother will be escaping himself. So now, I'm going to double check just because, you know, the demo gods and all. Okay. All right. All right. So now, while he's done his thing, we're going to go over to C2. A little bit of a delay there. So it's going to fire up. So it works a little bit like a web server, of course, right? Accepting browsing. It's going to go ahead and listen. And as soon as the connection is made, we'll see a prompt. It's a little bit slow in starting up. Hopefully, it'll come up soon. There we go. Can we get that on the screen? Okay. All right, now, here we go. So little brother has been started, the connection has been made, and big brother has reached out to the C2 and is going to relay anything. All right, so there I am with my access onto little brother behind whatever firewall that is there. All right. I'm going to move around a bit. We're going to go ahead and just look at the switch real quick. There's some timing and waits. It's very patient. Here we go. So we're in the red file system there. There you go. But things aren't forever. Not entirely. At some point in time, it's going to be noticed. What's this mysterious connection? You know, as an network administrator, you see these sorts of things. You might see a strange connection, you freak out, right? And you're going to go, let's reinstall the operating system. Well, of course, right? Because we don't really fix things so much, especially with devices like this, the desktop. So we just reimage, right? So we'll go ahead and reimage. It's an infection, right? That's what we do. So I'm going to go ahead and bring up ONI and then install another file system, another network operating system. This one happens to be the demo operating system. It's going to do its thing there. It comes up and we'll go ahead. I'm going to stop this because it's obnoxious. And then I'm going to get my command to go ahead and get that operating system. I did this because I didn't have access to the operating systems at the time that I did this. But I made sure that it operated just like Switch Lite. I wanted it to be realistic. So, it's going to just do a thing. We're going to move on to fixing this sort of stuff. And we'll come back and see little brother resurrected. Okay. So available solutions. All right. I have been characterizing this as poor choices, and that's what we have seen with the vendors. And this is about fixing that. So these solutions are addressing primarily vendors, and vendors what they're going to have to do. We have hardware, install environment, network operating systems, agents. That's your remediation stuff, right? The vendor stuff is remediation. And then for network administrators themselves, the architects, right? Changes to enterprise architecture for mitigation. Things that you're going to have to do in the meantime. Okay. Hardware, obviously, trusted platform module. Rob Sherwood at Big Switch Networks had these put in for most x86-based switches. There aren't any new PowerPCs designs. I at least have not heard of any coming up. So that's maybe difficult to do to get them added to PowerPC switches. But if we can, that'd be great because we want to start using TPM. We want platform security to make sure that any sort of modifications that ONI, well, if ONI is modified, that the boot fails. Right, so that we know something's wrong. Yeah. They are also working on, and so we get them on the hardware. The next step, of course, is to get them in use. And they are also working on getting in the standard. But it's a partnership, of course, between the vendors and the people making the standard, so it's a bit of a slow process, but they are working on it. And that's Cumulus Networks. They're the ones that developed ONI and got it adopted. So they're working on that. Install environment. It removed Telnet. All right. It's insecure. We can use SSH, it's okay. And then with SSH, increase key entropy. and force a password change, for God's sake. I think we are all capable of remembering a password or using a password safe if we choose not to. Factory reset. Who here has done a factory reset? Right? If your hand's not up, you're probably lying. All right, we forget these things, we screw up. Factory reset. You can do that. Remove IPv6 and TFTP waterfall. All right? Nothing wrong with having DHCP provide the installation URL. We can protect the DHCP server. We can make sure it's the only one running on the, right? They have ways of doing this. No reason why we can't use a DHCP server. And of course, a good one would be sign installations. The best one would be, but there's always problems with keys, right? And signing and that sort of thing. I understand there's problems there, but ultimately that would be the best solution. Operating systems. Before we hit that, let's check out little brother. Operating system has been installed again. Let's check out C2. Now, C2 is capable of issuing a reconnect command. If you enter commands and you don't get anything back, you know that there's been a disconnect. Likely, the network operating system has been installed again. I did that myself, so I know there's a disruption there. I'm going to go ahead and tell it to reconnect. It's going to close. Big brother's going to close his end of the socket. He's going to reestablish his connection to little brother. All right, so there we are. Survived. Thank you. It's so many months, you have no idea. So thank you. And we still have our access. We're persistent, right, even after an installation. All right. All right, so operating systems. Now, we obviously can't do everything. All right. These are ways to harden the environment. I'm an ops guy, all right, so we think hardening. As many as you can, right? Make this platform more resilient because there's a lot riding on this firmware. A lot more than other firmwares that we've seen. We've got bigger implications, right, for this firmware being compromised. All right, first one, changeable names. UID accounts. All right. Change the UID 0 account names. Give us the ability to do that. Reduce privilege accounts. It'd also be great if we could add users. Which you actually cannot add users. Melon actually can add a user, but you have two types. Admin and monitor. Which one do you think you're going to use to define, to configure, and take care of the switch? Admin, right? Admin has the ability to change passwords. Change the password of the original admin. Get your UID 0 back. Okay? Forced password change. Don't allow those to get stale. Don't think I mentioned this at Black Hat, but one thing I've seen in network ops is the password that they use, right? The shared passwords. First of all, they usually have a shared password, and the password generally sticks around a real long time. They have a lot of equipment. They have a big team. I've seen those passwords go for years and not be changed. Okay? So force a password change. And then, of course, remove UID 0 from the admins. Remove UID 0 from the admins. And then tighten shell access. Switchlight, I would like to see a one-time password. They have self-service portals for support. Why can't they self-service themselves a one-time password to get the shell access? If you're going to give it, make it a little more difficult, a more resilient. Human Linux, how about a wrapper? Also with a one-time password. Now Mellanox actually does a pretty good job of protecting, right, that wrapper. Right? There is a way to get shell access from the wrapper, but it was taking way too long for me to reverse engineer their code. So I took a shortcut. I said I was an ops guy, right? So, SoCat. If you unpack the firmware, SoCat's there. And you can plug that into Bash and there you're in. If you were thinking about maybe modifying or having Puppet modify password, right? Or Shadow, like add user, they thought of that. Right? But they missed SoCat. Agents. All right, this is common, right, in SDN platforms. They're not using TLS. All right, so they need to use TLS. They need to not only just use it for encryption, they also need to use it for auth, especially mutual auth. And then, of course, there's a concern with certificates and key distribution. But you've already got DevOps there, right, and SDN to do the heavy lifting. Have them also lift, the certificates and the keys. Okay. Enterprise architecture. All right. I see the management plane. We need more than a VLAN, right? We need to get as close as we can. I understand it's difficult to physical separation. It's already done, and that's why I say try to get there, right? Get as close as you can. What's wrong with jump boxes? If you have been in network ops, they have 20 monitors on that damn wall. All right? Network admins having 2 monitors on the desktop. Why can't you remote into a jump box, maximize that in one of the monitors, use it just like you would one of your other workstations? It may take a little getting used to, but it's going to up your security significantly. And then we have audit switches. All right? I said the A word. I had to learn to love audit. It was a painful process, but audit has good uses. They're your friends. Make sure their password changes. And then it wouldn't hurt to also hash only partition to make sure that it hasn't changed. Okay. All right, I have a couple minutes left, and I want to get to these last slides and probably run out of time for any extra questions, but we can always talk afterwards. You're seeing something here that's familiar, right? You're seeing vendors race ahead. And we want to talk once again about impact on security and keeping pressure on the developers, which is why we're here, right? We're here to freak them out, right? Sometimes piss them off, and talk about the difference that we're trying to make. Okay? Getting products, features to market is important. We get it, we all get it, right? They're there to make money, and they have to be out there first. But desktop operating systems, server operating systems have been through this before. They have something called best practices. I don't think you're reading them. I think you should. I think you should develop your own best practices. Start using them. Because you're not, we're starting this merry-go-round again. Right? Every year at these conferences, we hack it and then you fix it. So now it's your turn, of course, to do cleanup. I'm here to evangelize, right? Hire someone for security. A lot of the companies doing this are either startups or they're small business units within a large organization. You have a limited number of people. One guy for security. Bring that one guy in for security that's there all the way. How about some assessments along the way? Somewhere midway through the development lifecycle, maybe an assessment at the end before you release. And the key is before you release. We would honestly settle just for that one at the end. All right? And when you go try to sell it, security can be a feature too. All right? All right, so we want to make a difference here. We want you to learn from desktop and server operating systems. We want you to begin to harness these new platforms, right? DevOps and SDN. For the most part, what they're taking over, right, what they're taking responsibility for is defining the switch and configuring the network. They need to take over for the entirety of the platform. All right, they need to be responsible for the whole thing. Whether it's checking permissions, and being responsible for permissions, or some kind of coordination, audit, are they checking audit? Checking audit events, or they're following those up and making it part of the rest of the entire platform. Like Switch Lite could do that, right? Funnel up to Big Cloud Fabric, maybe a separate platform to consolidate all that. How have all that looked at? Or how about logging, right? We're checking logs on the individual platforms, or you are at least consolidating the logging so you have visibility there. So you are now taking responsibility for the entire platform, not just part of it, right? And then logic probes. That's kind of my general term here. I have some electronics background, so that's why that comes up. You can check things. You can check state. You can make sure that the platform is in the state you expect it to be. Right? You can, a good one, right? Hash the only partition. That's a nice thing to do, right? Make sure everything is intact. Yeah. So our final thoughts here. I think we are good on our time. It's a wrap-up. The security of the network operating system is critical, right? The security, as we've seen, has been neglected. And it's because they think the switches are safe. They're assuming that you're following all the best practices. They're assuming that it's an ideal situation. The solutions that you purchase at the different layers, right, defense and depth, are operating perfectly. That it's a perfect world and they're catching everything. And that's just not the case, right? A single piece of malware could easily make the crossover from Windows to Linux. I did it right here. I'm not the first, obviously. And when that happens, of course, that pivot, and network administrators make a great pivot, you then are able to compromise those switches, and you're able to get that long-term persistence, and the significance is immeasurable, right? Because you have visibility now, and outside of the entirety of the network. And we are here today trying to avoid that. And so hopefully we work together, we can avoid that. Links, you want to learn about all this stuff, the different products, because they are pretty cool products, right? And that is the end. Thank you for coming.